Hi, I'm Mary Powell, Environmental Manager with the Mile High Flood District, and I'm here today with Moneka Worah, and we're hoping to share with you some lessons we've learned on working on a number of projects within the Mile High Flood District boundaries.
Hi, I'm Moneka Worah, Natural Resource Specialist and Principal with ERO Resources. And as Mary stated, we are here today to discuss why are the wetlands dry, and several projects that we have worked on in the past or are currently working on, some that have maybe not succeeded for wetland riparian establishment, and some projects that have been very successful for the ecology and restoration of those projects. And what lessons can we take from those combinations for moving forward and creating successful stream restoration projects from the ecologist's perspective? We'll also be discussing multidisciplinary teams and both the pros to working with many disciplines and the difficulties or cons that may arise from having many disciplines on one project.
Our industry, particularly Mile High Flood District, has been working towards implementing a multidisciplinary team approach for projects. This includes having a contractor being brought in during design rather than waiting until the design is complete. This also includes having a variety of subject matter experts on the project, from hydrology, hydraulics, civil engineering, geomorphology, ecology, and landscape architecture. And these subject matter experts are on the project from conceptual level all the way through construction and monitoring.
And as our project teams are evolving to include more specialists and perspectives at the table, collaboration and effective communication between all team members becomes critical to successful planning, design, and construction. With so many people on a team, it can be difficult to ensure that everyone's voice is heard, especially when those voices may seem to run counter to accepted approaches, or to challenge assumptions, or to risk affecting cost and schedule. For most people, it takes practice, including some failures, to be comfortable raising a hand and taking a stand on a position in a multidisciplinary team.
Since ecologists are rarely in the driver's seat when it comes to planning, design, and construction, it can be difficult for us to voice our concerns or speak engineer talk to communicate what elements we believe are necessary for project ecosystem to be successful. What is considered successful for a project for geomorphology or sediment transport may not always equate to success for a wetland or riparian development, and vice versa.
So before we dive into project examples that we're going to go over with you, we'd like to take a moment to discuss high-functioning, low-maintenance streams and some terms that are more often being applied to projects and how those fit within the wetland riparian designs and their success.
So very briefly, we wanted to recognize that in these multidisciplinary teams, there are a lot of terms that are applied during design from the various disciplines, and how these terms intersect with each other is really critical through design. Each discipline is kind of focused on different terms. So ecologists may be focused on the wetland bench, saturation zone, ordinary high water mark, while the geomorphologists may be focused more on bankful elevation, interberm, channel forming flows. But how these terms intersect with each other is really, really critical for design and understanding each discipline and what they're meaning for the stream restoration design. And for example, if an ecologist doesn't understand what bankful elevation means, and the wetland mitigation is proposed at bankful, then it may result in wetlands being constructed too high for the elevation that they really should be.
Our first site is at Newland Gulch, downstream of Chambers in the town of Parker. In the Newland Gulch at Chambers Road project, we see a cross-section that's very common these days in naturalized channel design or higher functioning, lower maintenance stream restoration projects. And that includes a bankful channel of some sort of width, We have down below here an inner berm or lower terrace, and then down into the bed material of the stream. In this case, it's showing riffle bed material down in the bottom here. One thing that's really important about this cross-section and multidisciplinary teams is ensuring that there is a lot of conversation about what the intent of the inner berm is here. Oftentimes for the channel cross-section, for the geomorphological channel stability, the inner berm may just be a very narrow little point bar. For the ecologists on the team, this is where we may need to see some amount of wetlands form, either for desirable functions for the channel or to meet our wetland mitigation compensatory mitigation needs for the Section 404 permitting. The reason this conversation is so important is it's very critical the elevation of this inner berm or wetland bench to get adequate wetlands to establish. The elevation of this bench ought to be at most about a foot above saturated soil. And we see that a little bit here in the actual Newland Gulch channel design. We see again the bankfull channel. We see the inner berms here. In this case, they are a little bit above a foot above the channel, maybe as much as a foot and a half above the channel invert. They're very narrow in this case, not even 5 feet in this particular cross section. So again, a foot and a half above the channel invert might be fine in certain settings, depending on how deep the low flow during the growing season is in the system. However, for the actual as-built Newland Gulch, we end up again having the bankfull channel here. Down the slopes between the green lines, we have the inner berm, which in the case of Newland Gulch is dry. This bench is too far above saturated soil to support wetlands.
There were some opportunities that might have been missed, both in design and in construction, to have better accommodated both the stream stability goals of the project, which generally have been met, and the overall riparian vegetation and ecological goals for the remainder of the riparian corridor, which remain somewhat lacking in this particular project. So again, lessons learned, better communication, more involvement throughout the design process and into construction to make sure that the ecologists, the geomorphologists, and the design engineer are talking and they're out there together solving problems. This was built to design, and yet it isn't a fully functional system as I think it may have been intended in the long run.
Our next site is First Creek upstream of Tower Road in the city and county of Denver. In the First Creek upstream of Tower Road project, we have a similar cross-section as we had in the Newland Gulch project. We've got our bankfull channel width here, we have the inner berms, and then we have our channel invert. In this project, the channel invert is about a foot below these inner berms, which generally ought to be, if we have some base flows in here, should give us saturated soils up to this level. One thing you'll notice though is in this case, the cross section, the inner berms are only about 3 feet wide, which is quite narrow. In this case with First Creek, we were hoping to be able to support wetlands in some of these upper benches, which generally, since it's beyond the bankfull channel, there was concern that they would be a little bit too high. However, as designed, they're about a foot and a half, perhaps up to 2 feet high above the channel invert. So the design team determined that there would be adequate water in here to support saturated soils far enough away and high enough to support wetlands in this overbank area. These green shaded areas show the extent of wetlands we were hoping to have form in order to meet our compensatory wetland mitigation requirements for the Section 404 permit. As I describe in the next video clip, however, the conditions that resulted have not been enough to establish the desired amount of wetlands, and I provide some lessons learned.
We have some nice wetland fringe here, but then as you can see, the slope comes up a little bit, and we end up with uplands where we had intended to have wetland vegetation in here. So this mark missed by probably about 8 inches. We would have had a nice wetland bench here that would have faded into this inside bend. So it just points again how important it is to have the ecologists, engineers, landscape architects working together, not only during design, but also during the construction. If we'd been able to address this during construction, we would have had a much better result. This is one of my lessons learned personally, because I was the ecologist on this project, and I was concerned about these elevations, and I expressed my concerns, yet I allowed myself to be convinced that it would work. I did not express my concerns strongly enough. I feel like I should have done a better job on saying, no, we have to stop what we're doing and make this lower. However, I was not brought out until there was already the blanket in place. It was pretty much buttoned up before I got out here, so the impetus was like, well, we don't want to undo it, so let's just see what happens. And unfortunately, we're seeing what happens, and I believe we'll end up short on our wetland mitigation here, and it's because I did not push back hard enough and insist that the project be modified in the field.
Our next site is West Fork of Second Creek in the city and county of Denver. The West Fork of Second Creek project has a cross-section somewhat similar to what we've seen on Newland Gulch and First Creek. The difference here is we do not show a specific inner berm. Rather, we have a slight slope heading down toward the channel invert. One thing I do like about this cross-section that is really, I think, getting to the point about having to be very explicit about the terms and the conditions that we're trying to establish in regard to the ecological functions and the stream stability functions is the detail that goes into the width of the bankfall channel in this case, and also the elevation above the channel invert of both the base flow water surface elevation here, which is shown as at about a foot above the channel invert. And then we also have a very explicit measurement for the bankfall water surface elevation, which in this case is determined to be approximately 2.5 feet above the channel invert. This kind of specificity really helps with the discussion of what we can assume as far as behavior of the channel and what we might be able to expect for vegetation establishment.
We are here at West Fork of Second Creek, newly constructed natural channel design, and you can see that this stream has relatively low flows right now. It is expected to have higher flows at full build out. However, we still have to design for what are the conditions at this moment and where can we expect wetland development. And as you can see on the inside bend, the bench is about 1.5 to 2 feet above the channel bottom. And unfortunately, it looks too high for wetland establishment. That saturation isn't going to get to that level. It may be at the level for bank full, but for wetland establishment, we would need it to be around the 6 inches at this type of flow regime.
The Cherry Creek at Iliff project is similar to the others we've seen in that we had the bankful channel cross section with a lower inner berm or wetland terrace. The thing I'd like to focus on with this project, though, is what the project team did with regard to specificity about the planting zones. We very explicitly discussed the normal water surface elevation, which was assumed to be about 1 foot deep, and how that associated with groundwater that the wetland vegetation might be able to access, or what we would expect that saturation zone to be. So in this case, we established planting zones. We've got zone 1, zone 2, and zone 3s and 4. Zone 1 being the wetland zone that we would anticipate and hope establishes our wetland fringe along here. So this is, again, speaks to the level of detail that the team went into to understand the dynamics between the channel cross-section and our wetland and upper riparian vegetation as well.
Here we're on Cherry Creek just downstream of Iliff, project between Iliff and Quebec. This is the largest system that we're looking at. So keep that in mind when we're looking at the elevations. You know, obviously the elevations and the slopes are informed by how large the system is and how broad and high the bankful event is. However, we still have some similar lessons that we can apply from the sites we've previously visited. Now, the thing with Cherry Creek is we get some very large flows when they are flushing the outworks from Cherry Creek Lake. So that had to be incorporated into this design as well. How well these operate over time, we don't know, but we felt it was worth giving a shot to try to get some of the nice, gentle slopes up to these upper banks at the bank full elevation.
Our next site is Plum Creek at Chatfield in Douglas County.
In this cross section, you can see where Plum Creek, the main channel, was proposed to be relocated. And here you can see where the low flow was proposed, and then again constructing these inner berms, and then gradually coming up into a higher terrace into the floodplain. This cross section shows a little bit more in detail, again, where this low flow was constructed, a gradual slope up to these benches, with a wider bench on the inside bends, 10 to 30 feet wide, and then another bench on the outside bends, maybe a narrower width and with riprap protection. But then again, you see this gradual slope up to a higher terrace where you'd be connecting into the floodplain and creating riparian habitat. But this cross section shows how much of a small transition it is up to these benches that would then support wetlands. Here's also a nice visual of the planting scheme that was proposed along Plum Creek, and it was based on your conditions of groundwater. So what species were proposed was based on their proximity to the groundwater, with more wetland herbaceous grasses and sedges proposed in closer to that groundwater table, and what would be proposed in those benches, as well as willow stakes, and then gradually changing into more riparian species as you get further away from groundwater.
So as you can see here, this is a nice example of along the stream where you can see the gradient changing from the lower stream bed that's relatively dry right now to this lower bench where you can see that it has gotten continuous flows at a certain point, and we'd likely see wetland establishment happening here. It may change over time as the fluctuations in the inundation occur. And then you transition a little bit further up, you see more of a mesic terrace, but then you also see it kind of dip down further to where there's some more juncus species developing along the toe slope, where you can see it kind of lowering the grades and getting more wetland establishment. But this project was able to create this nice gradient and wetland riparian system through a lot of collaboration with the engineers and the ecologists. The ecologists were involved from the very beginning, from concept level all the way through construction on a continuous basis. And so there was a lot of those discussions with the ecologists and the engineers on what was going to make the most sense for ecological restoration and stream stability. And this project needed to have the sediment transport, the ability to keep the system stable, constructing riffle and pool system, but also allowing for these large wetland riparian benches for habitat restoration. There might have been a lot of times the back and forth and headbutting with ecologists versus the engineers, but through those hard discussions, we're able to come up with a design that met all of the goals of the project.
Next is Sulphur Gulch, another project in the town of Parker.
This project along Sulphur Gulch included constructing a concrete drop structure that also relocated a pedestrian trail and had the pedestrian trail with a box culvert over the drop structure, and then lowering and widening the low flow channel through here, and then rehabilitating an existing drop structure. And as you can see here, this was a defined low flow channel that was constructed, and then immediately adjacent to it were these wetland benches that were constructed within a wider terrace and bench gradually sloping up that was a wetland riparian terrace and bench along the riparian corridor. In this cross section, you can see again that low flow channel that was constructed, and then these soil lifts that were constructed on both sides of the low flow channel. And the soil lifts were then planted with wetland vegetation and willow stakes.
And this project was constructed several years ago, but you can see how well the wetland riparian vegetation has established and done really well here. The design incorporated having several benches, with a lower bench immediately adjacent to the low flow channel, about 6 inches to a foot above that low flow channel, and then slowly grading upwards to create that riparian corridor. And so you can see again that there's a nice wide wetland fringe developing along the low flow, and then you can see how the vegetation kind of slowly transitions from having that wetland understory to maybe more mesic vegetation. But overall, it was done really well in being able to create that multi-stage channel that we're looking for healthy wetland riparian vegetation establishment.
So from these projects that we have discussed, there's several lessons learned that we recommend thinking about moving forward with future stream restoration projects. One of them is to establish goals and how to meet them early in the project design, maybe at the kickoff meeting, and then reiterating those goals throughout the project. Another major takeaway is to communicate early and often so that there aren't any misunderstandings in your project team.
That's all right. And that also means being willing to speak up in your subject matter, either in meetings or in the field. Sometimes it's hard for ecologists or other sub-consultants to feel like we actually have enough role in the project to be able to speak up, but it's just so important, even if it means potentially causing conflict. This also relates to having, to making sure that every team member is, their opinions are solicited during meetings and that they're listened to.
We also recommend using graphs and maps to confirm your understanding of where wetland riparian vegetation is proposed, and being able to see the zones or elevations that each type of species is going to be planted at. We also recommend to really communicate with ecologists during construction on where the project is at and when they should come out. Usually we recommend at least during rough grade, final grade, prior to and during plant installation.
That's it for us. Those are our quick recommendations. We hope they've been useful, and thank you very much.
Hi, stop laughing. Oh my gosh. Blah, 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 blah.
Lucy, this is Lucy. She'll be joining us during our presentation today.
There we go. Okay, now it's on. It's recording. Dance for me.